Okay, so today we're going to learn about the addition rule of probability. So our learning intention is the knowledge of the addition rule of probability, and we shall be successful if we can correctly describe if events are mutually exclusive, correctly construct Venn diagrams or list sample spaces, correctly count the sample space and the entire set, and correctly calculate the probability of an event occurring. Okay, so mutually exclusive events. These are where we have two events, A and B, which cannot both occur. For example, drawing a red card and a club, because red cards are your hearts and your diamonds, and a club will be a black card. So we can't have a red card and it also being a club. We can't roll a number less than 3 and greater than 4. Those events are mutually exclusive. So, mutually exclusive events, if we draw in a Venn diagram, they will be the disjointed set. So, for example, we have set A and set B, and there's no overlap. So, for example, here, with that drawing a red card and a club, so we have the red cards, which are your hearts and your diamonds, and your club is mutually exclusive. Rolling a number less than 3 is 1 and 2, and greater than 4 would be 5 and 6. They are disjointed sets. There's no overlap. So mutually exclusive events, the intersection A and B, the intersection of A and B will be 0. There is no intersection. And it's called the empty set. The intersection is empty. So the probability of the A intersected with B would be also 0, because they are mutually exclusive. Remember that this symbol is the intersection, and this symbol is the union. So the probability of A and B, so A union B, A or B, is the probability of A plus the probability of B, and that's going to equal to 1. Okay, so if a die is thrown, we want to find the probability that the result is less than 2 or greater than 4. So if we were to draw a Venn diagram, probably the result is less than 2, well that's just 1, or greater than 4, which must be 5 and 6. So as they are mutually exclusive, so the probability of a number less than 2 union greater than 6, greater than 4, sorry, is the probability of A plus the probability of B, because they are mutually exclusive. So that's 1 over 6 plus 2 over 6, which is 3 over 6, which is also equal to a half. Okay, so let's do example 2. If a card is drawn at random from a standard deck of cards, find the probability that it is black or a diamond. So that's the probability that it is black union with a diamond. So that's the probability, because they're mutually exclusive, probability of a black card plus the probability of a diamond. Okay, so there are 2 suits of black, so that's 26 over 52 cards, plus there are 13 diamonds over 52, which ends up being 39 over 52, which is the same as 3/4. Let's look at number 3. If there are 3 coins were tossed, find the probability of throwing an odd number of heads. So let's do a quick Venn diagram. Let the set A be if I have 1 head. So that would be, for example, HTT, THT, and TTH, because that's 1, and the other one will be 3. So set B will be 3 heads. So we've got head, head, head. So all the other ones that don't kind of fit in go on the outside. So we've got all 3 tails, or we've got head, head, tails, or tails, head, head, or head, tails, head. So the probability of an odd number of heads is 1 head plus 3 heads. So we've got 3 out of 8 in total, plus 1 out of 8 gives us 4 over 8, which is the same as a half, 50%. Okay. Alright. So let's look at events that are non-mutually exclusive, so where there is an overlap. Okay. So the union of A or B is the same as the probability of A plus the probability of B minus the intersection between. So it's all of this plus all of that. Now, because we've added the intersection twice, we've got to subtract that. So we're minusing this part because we've counted that twice. Yeah, and that is actually the addition rule of probability. So when you have non-mutually exclusive events, the union, probability of the union of A and B is probability of A plus probability of B minus the intersection. So let's do some examples. So in a group of 50 students, 15 studied chemistry, 26 studied biology, and 8 who studied both. So let's say we have chemistry in group A, and group B is biology. So we know that 8 studied both, so that goes in the middle. Now we're going to subtract 8 from 15, which gives us 7. So we've got 7 students that only do chemistry. We've got 26, and we're going to minus 8 from that, so there's 18. 18 studied biology. And so 7 plus 8 plus 18 gives us totals of 33. I'm going to subtract that from 50. And so there is so 7 plus 8 plus 18, 33, 50 minus 17. So 17. Don't say your language. Alright, so we want to find the probability of a student who does chemistry only. So that's just, with our Venn diagram, we can read that. That's 7 over 50. biology only would be 18 over 50. Chemistry and biology will give us 8 over 50. Chemistry or biology, so we could do it with this, we could do the probability of A plus probability of B minus the intersection. So the probability of chemistry was 15 over 50 plus 26 over 50 minus 8 over 50. So we got 15 plus 26 minus 8, we get 33 over 50. Okay. Okay. Last example. So one card is selected at random from a pack of 20 cards, numbered 1 to 20. We want to find the probability that the number is less than 10 or divisible by 3. So let's do the probability. Let's look at the set of a number less than 10. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, and 9. And the set of divisible by 3 are your multiples of 3. So you've got 3, 6, 9, 12, 15, and 18. So we want to find the probability that the number 1 to 20, less than 10. So numbers less than 10 union, so or divisible by 3. Okay, so if we look at the probability of a number less than 10, that's going to be 9 out of 20 plus the probability divisible by 3. So that's when we've got 1, 2, 3, 4, 5, 6 out of 20. And we're going to minus the intersection. So there's 1, there's 2, and there's 3. So minus 3 over 20. Yeah, so 9 plus 6 minus 3, we get 12 over 20, which is factored down to 3/5. Okay. Let's look at the next one. A composite number. So let's look at the set. The set is of a composite number. That is a number that has more than 2 factors. So we have, one's neither prime nor composite. So we have 4, 6, 8, 9, 10, 12, 14, 15, 16, 18, and 20, and greater than 12. So we start with 13, 14, 15, 16, 17, 18, 19, 20. Okay, so the probability of a composite number union or greater than 12 is equal to the probability of a composite number plus the probability of greater than 12 minus the probability of composite or greater, and intersection. Greater. Okay. So there's 2, 4, 6, 8, 10, 11. So there's 11 composite numbers. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep. There are 1, 2, 3, 4, 5, 6, 7, 8. Yes, of course, 8 numbers greater than 12. And the intersection includes 14, 15, 16, and 18, and 20. So we've got 1, 2, 3, 4, 5. So 11 plus 8, 17 minus 5 is 14 over 20, which is 7 over 10. Okay. So to reiterate, let's look at our success criteria. Correctly describe if events are mutually exclusive, so that's when two events cannot occur at the same time. Correctly construct Venn diagrams. Yep, so if there's mutually exclusive, they'll create a disjointed set. Or you could do a Venn, if it's mutually not mutually exclusive, they'll have an overlap. Correctly count the sample space and the entire set, so listing the sample space of your situations. Correctly calculate the probability of an event occurring. So remember, we also have to remember the addition rule. So correctly apply the addition rule and that is the probability of the union of A and B is either the probability of A plus the probability of B if the event is mutually exclusive, and if they're not, then it's the probability of A plus the probability of B minus the intersection. Not mutually exclusive, and that is the addition rule. All right, thank you very much.